Okay, so it's disturbed from the top here, comes around here, that's R, and that bit there is the weight, which is mg, and we need an angle theta, that'll be theta there. I always like putting some things in here. We're given in terms of omega, so the acceleration going inwards, A equals R omega squared, velocity going around there, V equals R omega. I might want to use acceleration going inwards is V squared over R, but I'll certainly start off with R omega squared. I've got to show this, it's always going to be starting with energy, it's M3 after all, so total initial energy equals total final energy. We've got bits to it, we've got potential energy, or gravitational potential energy, and kinetic energy, and same thing over here, potential energy and kinetic energy. Like putting the formula down, half mv squared, potential energy mgh. And so initial energy, I'm going to take that to be my baseline there. So initial energy is actually 0. And then what have we got? That's going to equal the mgh. So it's going to be mg. And it's gone down, so it's going to be negative. And what's it gone down by? It's gone down by this bit here, which is going to be the whole thing, which is going to be A minus the bit which is here, which will be A cos theta. And that'll be plus a half mv squared. So v squared, we'll put that to the other side, v squared equals, times it by 2, get rid of the m's, 2g a minus a cos theta. It's done the first bit, but we want to have a omega squared, so we need to v equals r omega, so v squared equals r squared omega squared. So I can put that in there. And what's r? R is the radius, so it's a. So that gives me that a squared omega squared equals 2, take out an a g 1 minus cos theta, and one of those a's will cancel out with that one there to get a omega squared equals 2g 1 minus cos theta, which is what I wanted. Second bit, do it up here. Okay, I'm going to have to resolve. I'm going to resolve in the direction of the acceleration. So I'm going to resolve inwards, and that will give me a resultant force equals mass times acceleration. What goes inwards? It will be mg cos theta minus r, and that equals the mass. And the acceleration is r omega squared, and so r is in this case a, so that'll be a omega squared. I suppose make it clear to you, that's the acceleration, that now is the radius. So r equals mg cos theta minus ma omega squared, and we know what a omega squared is because we just worked it out here. So that says that r equals mg cos theta minus m times by 2g 1 minus cos theta, and so r equals 3 mg cos theta minus 2mg. Is that bit done? At the instant when P loses contact, so part 3, P loses contact, therefore R must be 0, therefore this bit 3 mg cos theta must equal 2mg, and so cos theta equals 2/3. So got that bit, and we want the transverse acceleration component of the acceleration. So theta is approximately 0.841, and we want the transverse component. Therefore we need to resolve tangentially, so in that direction there, and of course resultant force equals mass times acceleration, and so mg, and the bit we want is that bit there, so that'll be mg sine theta. So mg sine theta equals m times by acceleration, which is what we want. I'll put down dv by dt, so you can see it's not the same as the a from the radius. M's cancel, and so the acceleration equals g sine theta, which is 7.304. And then part 4, the rate of change of r with respect to t. I'll do it in purple. So we need to work out for part 4, we need to have dr by dt. To do this, we're going to have to use chain rule. I set it up like that, dr by dt, and obviously these are going to be thetas. So I've got to differentiate r with respect to theta. This is what r is here. So differentiate that will give us cos theta goes to minus sine theta, so that'll be minus 3mg sine theta times by d theta by dt, and for that is the same as omega. So in order to work out omega, I come here, I'll do it in purple here, so omega will equal, or omega squared will equal 2g 1 minus cos theta all over a, and then omega will be the square root of that. So that's what I need here, square root of 2g 1 minus cos theta all over a. And actually if we got cos theta is 2/3, then sine theta, this cos squared plus sine squared, will equal 1, so that will be root 5 over 3. The square this will get 4 over 9, the square this will get 5 over 9, that comes to 1. So now I can just put those into here, and that will give me minus 3mg times by sine theta, which is root 5 over 3, times by the square root of 2g on 1 minus cos theta is 1 minus 2/3, that's times 1/3 all over a, and that will give me 3, and the 3 will cancel out. I'm going to put that root 5 in with that root there to make that root 10 inside there, and the 3 will go into the bottom there, so that equals minus mg root 10g over 3a, and that's rate change of the normal contact force, so that will be newtons per second, like so. And that's question 7 and the whole paper done.